So dear students, let us solve some numerical problems related to the refraction through prisms. At first, let us review the formulas. First formula, deviation through a prism is given by the relation delta is equal to I1 plus I2 minus A, where I1 is the angle of incidence at one phase, I2 is the angle of emergence at second phase, and A is the prism angle, also known as refracting angle of prism. Second formula, minimum deviation formula, mu is equal to sin A plus delta m upon 2 upon sin A by 2, when I1 is equal to I2 is equal to I and R1 is equal to R2 is equal to R. In that case, this ray is parallel to the base. Next, deviation through a small angle prism is given by the relation delta is equal to A into mu minus 1, where mu is the refractive index of the glass of prism, and A is equal to R1 plus R2. A is equal to R1 plus R2. At normal incidence, I1 is equal to R1 is equal to 0 when ray is incident along the normal. Similarly, at the grazing incidence, I1 is 90 degree. At grazing emergence, I2 is 90. Now question number 1. For equilateral prism, find refractive index if delta m, that is minimum deviation, is 39 degree. Solution to question 1. Given A is equal to 60 degree being equilateral prism, minimum deviation is 39 degree, therefore refractive index will be sin A plus delta m by 2 upon sin A by 2, which is sin 60 plus 39 by 2 upon sin 60 by 2, which gives refractive index as 1.52. Solution to question number 2. Here we have mu as 1.5 and prism angle A is 60 degree. We have to find prism angle. So we have to find angle of minimum deviation. Now mu is equal to sin A plus delta m by 2 upon sin A by 2, which gives mu into sin A by 2 is equal to sin A plus delta m by 2. Therefore, mu means 1.5 into sin 60 by 2 is equal to sin A plus delta m by 2, or 1.5 into, this is sin 30, sin 30 gives 1 by 2 is equal to sin A plus delta m by 2, or sin A plus delta m by 2 will be equal to 0.75, which gives A means 60 plus delta m by 2 as sine inverse of 0.75, which is 48.59 degree, which gives delta m as 2 into this minus 60, means 2 into 48.59 minus 60 degree, that is 37.18. Question number 3. Find the velocity of light through the prism if minimum deviation is 34 degree and A is equal to 60 degree. Solution to question 3. We know refractive index is the ratio of velocity of light in vacuum upon velocity of light in medium, and also this is equal to sine A plus delta m by 2 upon sine A by 2. This gives B as C into sine A by 2 upon sine A plus delta m by 2. C is velocity of light in vacuum, equal to 3 into 10 to the power 8 meter per second, into sine A is 60 by 2 upon sine 60 plus delta m is 34 by 2, which gives B as 2.05 into 10 to the power 8 meter per second. Next, question number 4. Find the deviation produced by a prism of prism angle 8 degree and refractive index 1.5. Solution to question 4. Here delta is 8 degree. This is deviation through a prism, and refractive index is 1.5. This means that here for a prism angle A is equal to 8 degree and refractive index is 1.5. Therefore, the prism is a small angle prism, and for small angle prism deviation delta is equal to A mu minus 1. So delta will be equal to A means 8 degree into mu 1.5 minus 1 means 0.5 into 8 degree, that is 4 degree. Number 5. A ray is normally incident at one face of a prism and is emergent at grazing emergence at second face. Find the prism angle. Solution given for a prism I1 is equal to 0, will be equal to R1 for normal incidence, and I2 will be 90 degree for grazing emergence. So we have to find the prism angle. A is what? Now we know, we can understand this question with this diagram. This is prism angle. This is normal incidence. I1 0. Therefore, R1 will be 0. R1 will be 0 at point P. Now at second phase at point Q, this is another normal. Emergence is also, emergence is grazing emergence. This is normal incidence, and this is grazing emergence. That is, this angle will be 90 degree. Now clearly this angle, which is R2, must be equal to the critical angle. So at point P, Snell's law gives sin I2 upon sin R2 as mu air upon mu g, means A mu g, which is mu g upon mu air. Mu is g is 1.5. Yes, mu is 1.5 upon mu air is 1. So sin R2 will be equal to sin I2 upon 1.5 sin 90 upon 1.5 means 1 upon 1.5. This gives R2 as sin inverse 1 upon 1.5, that is 41.8 degree. Now A is equal to R1 plus R2. R1 is 0, so this is 0 plus 41.8. So A will be 41.8 degree. A will be equal to 41.8 degree. Next question number 6. Find the prism angle of a prism if refractive index mu is equal to 1.5 and the angle of minimum deviation delta m is equal to 37 degree. Solution. We know mu is equal to sin A plus delta m by 2 upon sin A by 2. This gives mu is equal to, this gives mu is equal to mu into sin A by 2 is equal to sin A. This can be written as sin A by 2 plus delta m by 2, or mu means 1.5 into sin A by 2 will be equal to this one. This can be opened with the relation sin A plus B means sin A cos B plus cos A sin B, that is sin A by 2 into cos 18.5 plus cos A by 2 into sin 18.5. This is 1.5 sin A by 2. This gives cos 18.5 gives 0.948. So this is 0.948 into sin A by 2, and sin 18.5 gives 0.317. 0.317 into cos A by 2. This is 1.5 sin A by 2. This can be taken to left hand side. So sin A by 2 is common. Sin A by 2 taken common. 1.5 minus 0.948 is equal to 0.37. This is equal to 0.317 into cos A by 2, and this gives 1.5 minus 0.948 gives 0.552 into sin A by 2 is equal to 0.317 into cos A by 2. Sin A by 2 upon cos A by 2 gives tan A by 2. Tan A by 2 will be equal to 0.317 divided by 0.552, that is 0.574. Therefore, A by 2 will be equal to tan inverse of 0.574, which gives 29.85 degree. That is, A will be equal to 2 into 29.85 degree, that is 59.7 degree, which is nearly 60 degree. Next, question number 7. An equilateral prism of refractive index 1.45 is surrounded with water of refractive index 1.33. A narrow beam of light is normally incident at one face of the prism. Find the deviation through the prism. Here, for normal incidence, on prism, I1 will be equal to R1 is equal to 0 degree. For equilateral prism, A is equal to 60 degree. We know A is equal to R1 plus R2, which gives R2 as A minus R1, that is 60 degree minus 0 degree, which is 60 degree. That is, at the second phase, R2 angle of incidence in glass, which is R2 is 60 degree, like this. This is normal incidence. Normal. I1 is 0. R1 is 0. This is another normal at point. This is point P and this is point Q. Another normal. This is R2 in denser medium. Now critical angle sin C will be equal to sin C will be equal to sin C is equal to 1 upon mu, which is 1 upon mu means mu glass upon mu water, 1 upon, or this is mu water upon, this is mu water upon mu glass. Mu water is 1.33, mu glass is 1.5. Therefore, C will be equal to sine inverse of 1.33 upon 1.5, which gives 66.5 degree. Thus, in this case, R2 is less than critical angle. So, R2 is less than critical angle and refraction will take place at point Q. If C were less than R2, then total internal reflection would have been taken place at point Q. But in this case, R2 is less than C, therefore refraction will take place at point Q. Now this is initial direction. Suppose this is I2. Now at point Q, Snell's law gives sin I2 upon sin R2 is equal to water to glass. Mu water to glass means mu water upon mu glass upon mu water, which is 1.45 upon 1.33. Therefore, sin I2 will be equal to 1.45 upon 1.33 into sin R2, 1.45 upon 1.33 into sin R2. R2 is 60 degree. We get sin I2 as 0.94, which gives I2 as sin inverse of 0.94, that is 70.05. But deviation is equal to I1 plus I2 minus A. This will be 0 plus 70.05 minus 60, which gives deviation 10.05 degree. Thus, the deviation is 10.05 degree.